Hi, this is Mrs. Bolin with your notes for 4.3 function notation. So first of all, in the warm-up, determine whether each function is linear or nonlinear. Remember, for it to be a linear function, it has to make a straight line that is not vertical. So this one has some curve in it. So any line that has a little bit of curve is nonlinear. This one is a straight line. It is not vertical, so this one is linear. So remember, the word linear has the word line in it, and we're talking about a straight line, not a curvy line. Question number 3, if I have to decide if it's linear or nonlinear, I'm going to look to see if it has a constant rate of change. So I add 1, add 1, add 1. So let's look down here. We went up by 3, up by 3, up by 3. This one does have a constant rate of change where it goes up or down by the same amount each time over a certain interval. So this one is linear. Question number 4. What do you guys think? Linear or nonlinear? I hope you said nonlinear because look at this. It has an exponent on the variable. So that would be nonlinear. Okay. Our notes for today, we're going to be talking about function notation. And what this is just a way for math people to use fewer words. So you'll see it right here. This does not mean f times x. This is pronounced f of x. The f stands for the word function. And we say that f is a function of x. And really, that just has to do with the output. We want to know what is the value of the function when we plug in a certain x value. Okay, and so the output of a function is the same thing as with y. So sometimes in an equation, instead of writing like if I had y equals 2x plus 3, another way to write that same thing would be f of x equals 2x plus 3. Remember, the y is the output, f of x just stands for the output, but it allows us to put in a little bit more information. Whatever value we plug in the parentheses represents what we're plugging in to the function. So for example, if I wanted f of 7, that would mean what's the value of this when I plug in 7? So for example, I'll read that again. If I were writing this whole sentence, what is the value of y equals 2x plus 3 when x is equal to 7? We could simply say, well, if our function is defined as 2x plus 3, then what's f of 7? Okay, it's not being multiplied. We cannot divide by 7 on both sides. It's just telling us that it's a function of x and what is the value of the function for that particular input. Okay, so let's do some problems. I know it seems kind of confusing right now. Once we do some problems, hopefully it'll make a little bit more sense. So for example, if I wanted to know, here's the function, f of x equals this, we'll find out when x equals 2 and when x equals -2. So 2 separate problems. I'm going to take this, and everywhere there's an x, I'm going to plug in the 2. Okay, so I could say, well, if f of x is this, then f of 2 would be -4, and instead of my x, my input, I'm going to plug in a 2. And then I'm going to copy the rest plus 7. So then I'm going to solve that. I know that I need to do my multiplication first. So -4 times 2 is -8 plus 7, which gives us -1. Okay. The second problem told me to do is the same thing, but when x equals -2. So I'm going to find f of -2 equals 4 times, -4 times -2 plus 7. So a negative times a negative is a positive. So when I do that, I get 15. So that would be my second answer. Let's try another one of those. Okay, what I would suggest is you guys try it first. Hit pause on the video right now. Try this problem. See if you can figure it out. If not, press play. Or if you can, still then press play and see if your answer was correct. Okay, so we are going to take -4 and I'm going to plug it in everywhere there is an x. Okay, so I'm going to say, well, f of -4 is equal to 2, and then instead of that x, I'm going to use parentheses and plug in -4 minus 5. So 2 times -4 is -8. -8 and -5 make -13. So that was my answer for that one. But remember, this is actually 2 problems in one because they want me to do the same thing now when x equals 3. So I'm going to write it again. F of, instead of x, we're going to plug in 3. F of 3 is equal to 2 times 3 minus 5. 2 times 3 is 6. 6 take away 5 is 1. So don't you guys feel so fancy when you write all this math stuff and you're like, I totally know what that means. Okay, question number 3 says, let F of T be the outside temperature, F degree or in degrees Fahrenheit, T hours after 6 a.m. So explain the meaning of each statement. So these ones can get a little bit tricky, you guys, so try to bear with me. The T is how many hours past 6 a.m. So if T is 0, okay, that means 0 hours past 6 a.m. So that would be at 6 a.m. It is how many degrees? That's the temperature. 58 degrees outside. So 58 degrees Fahrenheit. I guess I should have a capital A. At 6 a.m., it is 58 degrees Fahrenheit. Okay, the next one then would be 6 hours past 6 a.m. Well, that would be 6 plus 6 is 12. So at noon, and does it tell us the temperature? No, so we just write in. So we would say it is in degrees Fahrenheit. They don't tell us, we just write what it has in there. Okay, so then we need to think about, well, what would 3 hours past 6 a.m. be? Well, this would be like 9 a.m., right? And then 9 hours, 6 plus 9 is 15, but minus 12, because at 12 we restart it, right? Unless you're like in military time. So this would be 3 p.m. Okay, so the temperature at 9 a.m. is less than the temperature at 3 p.m. So another way you could say that, you could say it is colder at 9 a.m. than 3 p.m. And you guys are like, no doubt, I could do that without even using any math. Like, it's going to be colder in the morning than it is in the afternoon in general, unless you had like some big storm blowing through or something. Okay, question number 4. This says 4f of x equals 6x plus 9. Find the value of x for which the function is 21. So they're telling us that f of x is 21. So I'm going to take f of x and I'm going to plug that in, not for the x, but for the whole f of x. Okay, so instead of writing f of x, I know that the function is 21. I need to figure out what value of x makes that true. So I want to know, what could I plug in so that when we get it out, it's 21. So I'm going to multiply it by 6, and then I'm going to add 9, and it's going to give me 21. So the first thing I'm going to do is take off the last thing I did. So instead of a plus 9, I'm going to go minus 9. So I'm going to say, well, that was 12. Okay, and if I times by 6, well, then I better divide by 6. So x is equal to 2. So that's the value of x, which makes the function equal to 21. All right, question number 5, then we're going to start on our homework for today. And if you guys are confused, I'm so sorry, but it's completely normal. This is a hard unit to understand. It's a completely new way of writing math that you probably haven't seen before. So it's okay if it's a little bit confusing. Just keep trying the problems. The more problems you do, the better you'll get. Okay, promise. So complete the table for this function. So I'm going to plug in -2, -1, 0, 1, and 2, but I'm going to start with the easiest ones. Okay, I'm going to start by plugging in 0. So I'm going to say, well, f of 0 would be 2 times 0 plus 5. Well, 2 times 0, that's just 0. 0 plus 5 is equal to 5. So I'm going to put that right there. Okay, now I'm just going to skip the negatives for a little while. I'm going to plug in a 1. Okay, so now I'm going to plug in f of 1 equals 2 times 1 plus 5. Well, 2 times 1 is just 2. 2 plus 5 is 7. Okay, now I'm going to plug in the 2 because the 2 is kind of easy to plug in also. So I'm going to go f of 2 is equal to 2 times 2 plus 5. Again, I'm getting that from right here. I'm just plugging in parentheses my value where the x is. And so 2 times 2 is 4. 4 plus 5 is 9. Okay. Do you guys see a pattern? It went up by 2, up by 2. So I can go down by 2 and down by 2. Okay, if you don't see the pattern, it's okay. Just plug in those numbers and you'll still get the same answer. Like if I wanted to, I'll go ahead and show you for this -1. F of -1 equals 2 times -1 plus 5. Well, 2 times -1 is -2. -2 plus 5 is 3. So that's what I got using the pattern. But sometimes I like to do the easiest ones first, just to kind of make sure that I'm doing it correctly. And then I go back and fill in the negatives. But you can do it however you want. I know sometimes you're like, no, I have to do it in order. That's fine. I get that. Okay, we're going to go over the homework now. We are just going to do the odd problems together. I'm expecting you guys to try the even ones on your own, but I'm going to give you an odd one to look at as an example, and then you try it on the even. You should be doing all of them. There's only 10 problems for your homework for today, so make sure that you're doing all of them. Okay, question number 1. Here's the function up here. This function is called r instead of f. That's okay. It could be any letter on the outside. That part doesn't really matter. This just tells us, look back at the function that says r, right? Like if this was a b, we'd be looking over here at this one. Okay, so, and then this tells me anywhere there's an x, plug in a -2. So I'm going to copy down this negative. Then I'm going to put parentheses where the x is. I'm going to put a -2. And then I'm going to copy the -7. Okay, so minus a negative is the same thing as having a +2. Okay, so I have 2, and then I've got -7, and then 2 minus 7. I'm going to write my answer over here to the side, even though normally we like to write it straight underneath. So r of -2 would equal -5. Now we're going to plug in 0. -0 minus 7. Well, -0 is just 0. 0 minus 7 is just -7. Here's my first answer. Here's my second answer. And now I'm going to plug in 5. -5 minus 7. Note that the only time I needed parentheses was when I was plugging in a negative value for x. If I'm just plugging in a positive and there was no other number there, you can just plug in the 5, making sure that that negative sticks to it. Okay. And then I have a negative, and a negative makes even more negatives, so I have 12 negatives. Okay, so question number 2, you guys are going to try on your own. Remember that you're just plugging this in for x. And this 0.5 is the same thing as just saying half. What's half of 2? 1. And because it was a negative, it would be negative. Okay, what's half of 0? 0. What's half of 5? 2.5, 2.5. Okay. Question 3 we're going to do together, and this one is a little bit confusing. Whenever we have those word problems in function notation, it's a little bit bizarre. We need to think about it though, okay? So this says, let's see if T be the number of customers in the restaurant T hours after 8 a.m., okay? So if it's 0 hours after 8 a.m., what time is it? 8 a.m., okay? So I'm just going to put a little 8 a.m. there just to help me remember. And then remember, the function represents the number of customers. So how many customers are there? 0 customers. So I could say at 8 a.m., there are no customers. Okay. For this part, it's saying the number of customers 3 hours after opening, well, 8 plus 3 is 11, so this would be 11 a.m., is equal to the number of customers 8 hours after opening. So 8 plus 8 is 16, minus 12 would be 4 p.m. You could also say, well, there's 4 hours to get to noon, and then 4 more hours past that would be 4 p.m., so 4 p.m. So remember, though, that the function represents how many customers. We don't know how many customers, but we know that the number is equal. So you could say there are the same number of customers at 11 a.m. and 4 p.m. The number of customers is equal. Oh, sorry. Okay, question number 4. This problem is, I'm just going to help you set it up, but you're going to do it on your own. Remember that it's not telling us the value of x, it's telling us the whole function is equal to 24. So you're going to plug that in, not for x, but for the whole entire function. So you would write that, plug in the 24, and then you would copy the rest of the function, and then you would solve for x. That's not done. You still need to solve it, but I wanted to help you set it up. This one, same type of problem, okay? It's telling us the value of the function, the whole function, not x, the whole function is 18. So it's giving us the output, not the input. Okay, it's telling us you find the value of x that makes the whole function equal to 18. So I'm going to add the 12 to get 30. And then I'm going to divide by the 6. And so I get x is equal to 5. So the value of x that makes that true would be 5. Okay, question number 6, you guys are going to try on your own, but it says find the value of x. So we want to know what x is, but we know that the function is equal to 7. Remember, f of x is the same thing as y. So you're going to look for when the function is 7, okay, when the function's 7, what is the value of x? That's what they're asking. What's the value of x when the function is equal to 7? Okay, so we're going to do another one of those, number 7. This one says a little bit, same thing. Find the value of x so that f of x equals 7. Okay, so the function f of x is the same thing as y. So here's 1, 2, 3, 4, 5, 6, 7. So I'm going to go over here to the function. Here's when the function's 7. And I need to find what's the value of x that gives me that value. And so this one happens to be -1, -2, -3. So x equals -3. I know the value of the function, which is the value of y. I just need to find what's the x value that makes that true. Okay, question number 8. You guys are going to do that one on your own. But just a hint, start your function like this. And then when you plug in these values, is there anywhere even over here to plug it in? Are there any x's? No. So no matter what I plug in, what does it always equal? It always equals -5. So you finish the rest of that chart, but no matter what I plug in for x, the function always equals -5. That's what that one is. Okay. Question number 9. This is more like the one we did in the practice problem. -2, -1, 0, 1, 2. Again, I like to start by plugging in the easiest ones. Like if I take 0 and go 3 times 0, that's just going to be 0. And then if I add 2 to it, 0 plus 2 is just 2. Okay, then if I plug in the 1, so I'm going to go W of 1 equals 3 times 1 plus 2. Well, 3 times 1 is 3. 3 plus 2 is 5. Then I'm going to do the same thing for 2. And I have 3 times 2 is 6, plus 2 more is 7, 8. And you guys can see the pattern. I added 3, I added 3. So if I'm going to do the pattern now, I can go backwards 3. So -1 and -4. And you guys can always plug in the numbers. Like if I plug in -2 times 3, I get -6. And then if I add 2, that gives me -4. Okay. Last problem is an even problem. So you guys are going to do this one on your own. But just a hint, this says, if 2D is a solution to the equation represented by the graph below, what is the value of D? Well, you're going to look for when x equals 2, what is the value of the function? So what is the y value? Okay, so that's what you guys are going to answer. I'm not going to tell you, but hopefully that should be a good hint to get you guys started. All right, and that is it for your 4.3 notes.